head or tail. If the pulse is divided into groups, and each group pulls a coin 10 times, the other 20, the other 50, and 100 times, then observe the results and record them in the following table. Here, if we pulse it 10 times, the number of occurrence of heads. Okay, I have head or tail. That means if it is head, that means it's half, okay, or 1/2, because I have two possibilities. I have two possibilities, head or tail, okay? So if I have head, okay, it's half the probabilities. One from two options, or two possibilities, or two outcomes. Okay, two possible outcomes. So it's 1/2. It means it's half. So if it is tossed 10 times, the number of occurrence of head, it will be half. Okay, times 10. Half times 10 means 5. And the number of occurrence of tails is the same. If it's tail, it means 1. From the two possible outcomes, it means half. 1/2. Half times 10 equals 5 or so. Okay? So, they are the same. Okay? Their probability are the same. 5 and 5. If it is 20 times the same, half, the probability of it will not change. So it's half. Times 20 will be 10 and 10, and so on. Half times 50, 25 and 25, 100, 50 and 50, and so on. Okay? Note, increasing the number of tossing a coin tells the fact that the number of occurrence of heads is nearly equal to the number of occurrence of tails, because it has the same probability as the other outcome, okay? Because they all have the same probability. Okay, let's here do this exercise. I take this over 1,000. As we said in the point, we said if it is head, okay, I have 2 outcomes only. So the total is 2. And I have only 1. So 1/2. This is the probability. Here we have what we asked over the total, which is 1,000. So the probability is 80/1,000. It means 8/100, 0.08, or 8/100. This is the probability of this. Okay? The next one. What is the probability to tear down after 400 working hours? Okay. And this is also 8%. That means I want to tell you that the probability can be in a decimal number or a fraction or percentage. We can represent the probability by 3 ways: decimal number, fraction, or percentage. Any one of them is right. Okay. Number B, this is A. Number B, if I want after 400. Okay, let's see here. Here it's from 150 to 400. Here from 400 to 1,000. And here also more than 1,000. So both of them, all of these number of hours are greater than or working more than 400 hours. So here I add 350 and 320, it means 600. 350 plus 320 equals 670. Okay, so the probability equals 670 over 1,000 equals 67 over 100 or 0.67 or 67%. Do you understand? Okay. Here, rolling a number from 1 to 6 to 150 times. How many times are predicted to get an even number? Okay. What are if I have a dice? Okay. This dice numbered from 1 to 6, as we know. Okay, from 1 to 6. What are the even numbers? 1, no. 2, 3, no. 4, and 6. So it's 3 over 6. The probability of getting an even number is 3 over 6. It means, I simplify it, it's half. It's half. This is the probability, but it's rolling 250 times. That means I multiply, as we did at the beginning of the session, if you remember the coin, okay, 10 times or 20 or 100 times. Here I multiply by 250. So it will be 125. So the probability equal here I get the probability, then simplify it and multiply by how many times I log it, okay? And we get the probability, okay? It's very simple. Okay, here. A survey was applied to ask 10 students about the foreign language they prefer to study. 5 students prefer English, 3 students prefer French, and 2 students prefer German. If the total number of students in the school is 600 students, how many students are predicted to prefer German? So first of all, here, 2 students prefer German. Okay, 2 over what? The survey done over 10 students only. So it's 2 over 10. 2 over 10. I simplify it, it will be 1 over 5. So this is a probability of the survey. But the students in the school are 600 students. So I multiply this by 600. Okay, it will be, okay. Calculate it on your calculator. So it's 1 over 5. Okay, 1 over 5 times 600 equals 120. So 120 students. This is a probability. 120 students in this school prefer the German as a language. Okay? Okay. Iman, Amal, and Maha clean their school in turns. They roll a number cube with 2 faces numbered 1, 2, 1, 2 faces 1 and 2 faces 2 and 2 faces 3. Iman does the cleaning if the face number 1 appear, and Amal does the cleaning if the face number 2 appear, and Maha does the cleaning if the face number 3 appear. Okay. How often do you predict each one does the cleaning within a 30-day month? Okay. Here, the cube is numbered from 1 to 3. 2 faces 1, 2 faces 2. So, they are equal. They are equal in turns. Okay? So it means if I calculate for 1, the 2 others will be the same. So, it's 1 over, or 2 over 6. It means 1 over 3. So the probability of each one is 1 over 3, right? 6 faces of the cube and 2, the number of faces, the share of each one. So 2 over 6 means 1 over 3, okay? Now, 1 over 3 times 30 days. 1 over 3 times 30, it means 30 over 3 equals 10 days. So, each one will clean the, will clean the school 10 days a month. 10 days a month or 10 days per month. Okay? And this is the probability. Okay. Now, we will take the theoretical probability. Theoretical probability. The last lesson was experimental probability. Experiment, I do it and get the probability. Now it's theoretical. Let's see. Here, if you have a bag contains 5 white marbles and 7 black marbles and 3 red marbles. All marbles are equally likely in size. Randomly a marble is selected. Randomly I select a marble. Calculate the probability of selecting. Okay. Now, that means theoretical, it means I can calculate it without red marbles and do it by myself. Okay? A black marble. Okay. I have here, draw a table, okay? The number of white, black, red, and the total. Okay, so the first one, a black marble. We said to calculate the probability. I asked about the black, so I get the number of black, which is 7. And what is the total? 15. So over 15. 7 over 15. This is the probability. I write here probability. What? 7 over 15. If I can simplify it, I have to simplify it. But here 7 over 15, I can simplify it. Okay? The next one, yellow. Here, do I have yellow? Do I have yellow? No. It's 0 over 15. It means 0. Okay? It means impossible if you say impossible. Okay, it's an impossible event, but the probability calculated with numbers. So, you can't write impossible, you have to write 0 and here, see, a white or red marble. White or red. It means I write both of them. 5 or 3. 5 or 3 means 5 plus 3 over 15. 8 over 15. And this is also in the simplest form. Okay? This is the probability of white or red marbles. Okay? Now, a box contains 20 cards numbered from 1 to 20. Randomly a card has been selected. Calculate the probability of selecting a prime number and a number divisible by 7. Let's see the first one. The probability. Okay, I want to see from 1 to 20 all the prime numbers. Let's see that. 1, no. 2, yes. 3, yes. 4, no. 5, yes. 6, no. 7, 8, no. Any other even number is not a prime number, only number 2. Okay? So 2, 3, 5, 7, 11, 13, 17, 18, 19, and 20. Okay, so they are 8. They are 8 over 20. 8 over 20, I have to simplify both of them, divide by 4, so it will be 2 over 5. This is the probability of the first one to get a prime number from cards numbered from 1 to 20. The next one, a number divisible by 7. Divisible by 7. Okay, it's of course divisible by 7, it means the products of table 7. Okay, so it's 7, 14 only. Okay, 7, probability equals 7. 7 and 14, they are 2. They are 2 over 20. It means 1 over 10, and this is the simplest form. Okay? Here, in the opposite figure, the spinner is divided into 6 colored, 1, 2, 3, 4, 5, 6 colored sections. What is the probability that the spinner stops at red, black, or green? Let's see one by one here. The probability of getting red. Okay, let's see how many red sectors here. 1, 2, 3. 3 sectors. The number of what I asked about here, the red are 4, and the total of sectors 6. So it's 3 over 6 means half. This is the simplest form, and don't forget. Okay? The next one. Probability of getting black. Here, do I have black? No, so the probability here will be 0. 0 over 6 or 0 over any number, so it will be 0. C, the probability equal green. How many green sectors do I have? 1. And total 6. So 1 over 6 is the probability of this. Okay? Here, circle the true answer. Tossing a regular coin, the probability of landing head. If I toss a regular coin, so what is the probability of landing head or of getting head? So the coin has 2 faces, okay, and the head is just one of them, so it's 1 over 2. 1 over 2. Number B, or letter B, drawing a regular number 2. The probability of getting the number divisible by 3 is, okay, the regular number of cube, the cube has 6 faces, it's like the dice, so it's from 1 to 6. So the number divisible by 3 is 3 itself and 6. I have 1, 2, 3, 4, 5, and 6. Only 3 and 6. It means 2 over 6. In the simplest form, that means 1 over 3. So it's 1 over 3. The last one, a classroom holds 40 students. 25 are boys and the rest are girls. A student has been randomly selected. The probability of getting a girl. I have 40 students, 25 boys, and the rest are girls. What are the rest? It means 40 minus 25. 40 minus 25, 50 equals 50. So, the probability of getting a girl, so it's the number of girls over the total. Okay? Both of them divided by what? Divided by 5. Okay? Equals here 3. so much and let's meet in the next year inshallah. Goodbye.